All right, guys, we are going to be going over an AP style problem that is derivatives and intermediate value theorem from a table. So what you're going to kind of do is you're going to watch this video. You're going to pause when I ask you to pause and work on things. And then you're going to grade yourself on an AP style rubric. So the very first thing is we're going to read this problem here. A metal wire length of 8 centimeters is heated at one end. The table above gives selected values of the temperature, T of x, in degrees Celsius of the wire, x centimeters from the heated end. The function is decreasing and twice differentiable. Guys, do not worry about this twice differentiable now. What we need to note that it is differentiable, so therefore it is continuous. Write t prime of 7 as a limit using the difference quotient. Estimate the value of t prime of 7, show the work that leads to your answer, and indicate units of measure. So it looks like we have about 3 different things coming here. We have write t prime of 7 as a limit, we have estimate the value, and then show the work with units of measure. Right off the bat, I'm thinking that this is probably going to be 2 or 3 points. I snipped in some of these definitions that apply to this unit from your master formula sheet. You guys may not remember I gave that to you on the first day of school, but I'll show you where to locate it. If you go to that content library, you should notice that there's this AB cheat sheet. The entire sheet is attached in a PDF, but I have snipped all the pertinent information for the following units that we're working on now, and I'll continue to update that as we go. But just know that that is where that information is living right now. So I pulled limits definition of the derivative, and then I also pulled intermediate value theorem. Because this has limit definitions, average rate of change, tangent lines, and this has intermediate value theorem, which I'm thinking is probably going to have something to do with this because it's giving me an interval and then a value and then equation of the tangent line. So I have all my information here. Let's use it and get this done. Right, t prime of 7 is the difference quotient. So I'm already looking up here and I'm like, okay, I know that I should be using one of these, either the first or second definition of a derivative. Because I am not given the function initially, but I am given an input, I'm going to be using the second definition and evaluate the derivative at this point. So I'm going to give you guys a second to plug this in and write it, and then take a look and see if you did the same thing as me. Take a second and pause this video and write t prime of 7 as a limit using the difference quotient. Check your work. Did you get my answer? We have t prime of 7 is the limit as x approaches 7 of t of x minus t of 7 over x minus 7. Now, because I don't know exactly what t prime or what t of 7 is, we know that 7 is going to live somewhere between the 6 and 8. So I'm actually going to write it more of like an average rate of change here. And I'm going to say that this is going to be approximately. It's good to note this because this is not an exact value. This is going to be t of 8 minus t of 6 over 8 minus 6. So we're now saying that the limit as x approaches 7 is going to be found by using this average rate of change formula. I'm going to get those and plug them in. And get about negative 7 over 2. We're going to say this is going to be degrees Celsius per centimeter. If I were scoring this section right here, I'm just going to call this a 3-pointer altogether. We would get 1 point for setting up the definition of a limit. We would get another point for using the average rate of change formula here. And then we get another point for our answer with units. Note that if your answer does not have units, then it does not count because it's said to indicate units of measure. So here's my final answer. But we're not only getting points for that answer, we're getting points for each of these pieces. Indicate how many points you got out of a total of 3. This next piece asks, must there be a distance x for somewhere between 1 and 6 for which t of x equals 100? So we're looking for that output somewhere between 1 and 6. So I'm going to draw that here. This is our interval we're looking at. And we're seeing, like, is there an output, or is there a possibility that my output could be 100? I pulled the intermediate value theorem for this because the intermediate value theorem says that if my function is continuous, and I know that it is, so I'm going to go ahead and say here, t of x is continuous over the interval 1 to 6. Because it's differentiable. So some sort of definition of differentiability. So we are continuous, but my function goes from 93 to 70 to 62. It does not go up to 100. I've told earlier that this is a decreasing function. I don't know. It could at some point, right? It's at 93. It looks like it's just going down from 93. It could spike up to 100, but I cannot prove that because the intermediate value theorem you can only prove if the output that we're looking for is between. So for example, if this value in the 1 was like a 108, we would know that it passed through 100 at some point, but there's no proven indication that it is going to pass through 100. So even though it's continuous because it's differentiable, I'm going to give you a second, and I want for you to use some sort of summary from this intermediate value theorem that states something about the fact that you cannot justify that the output could be 100. Take a pause here. Taking a look at this answer here, this would probably be, let's call this a 2-pointer. It would probably be a 1-pointer on the AP test, but since we only have 3 parts, let's give it a 2-pointer to break it up a little bit more. We would need to name that this is continuous over this interval. So you'd get a point for naming something about continuous. There's another point by saying that you cannot prove by IVT. So this cannot prove using IVT because the rationale is that that output of 100 does not fall between those outputs of 93 and 62. So some sort of an explanation and some sort of, we're naming that even though it is continuous, we cannot prove by IVT that that output exists between those 2 points. Our last part says, given the function, we're given this whole long function, I'm not even going to read it. What is the equation of the tangent line is at x equals 5? So we need a few things here. I'm going to come in here and write my equation of my tangent line. Let's look at my formula sheet. It says that we're going to use a point and then that slope of that point and then plugging it in. How we have seen this, let me get this pasted in here really quick. How we have seen this is we have seen this represented as we're saying, okay, let's take this. Oh, had a little hard time with that. Let's take this and write it in that y minus y1 equals m times x minus x1. So same thing here. We need a point, we need the slope, and then we're just going to plug those in. So let's first get our point, and I'm going to get that point by doing a few different things in my calculator. Let's input positive 5 in for that value, and I'm going to give you guys a second to do that. So we're going to input positive 5. It says calc is okay. So step 1, plug in that positive 5. Take a pause here and get me that ordered pair. We could have just used our table, and we see that t of 5 equals 70. So that's going to be my first thing I'm doing here. I have that ordered pair, and I'm going to come down and plug that in. So I know that we have a 5 and I know we have a 70 in my equation. Let's write the rest of the structure out. The next thing I'm going to do is I'm going to get my calculator and solve for what is that derivative. So I'm trying to find what is t prime of 5. You're going to get in your graphing calculator and you're going to go to Math, and you're going to scroll down to number 8, which should be in Derive. I'm going to give you guys a second, pause now, and input that equation, and then also say that you are evaluating at x equals 5. So we're plugging that into our calculator to get that value. Rounding to 2 decimal places, I get that t prime of 5 is approximately negative 7.750. After I get that, I know that that is my slope, so I am just going to plug it in, and it looks like I did not leave myself enough room. Totally fine. We'll just rewrite it. So my equation is going to be y minus 70 equals negative 7.750. These 3 decimals are important. They want to see at least 3 or 4 decimal places if you're ever rounding on the AP test. Guys, give it a box, and then you are done. Let's score this really quick. We probably would have gotten, let's say, 2 points for this one total. You would have gotten 1 point for the equation, and then 1 point for evaluating using the correct point. So give yourself a score here. How many points would you have gotten out of that? 2. In total summary, I want for you guys to take a look at like how many points that I've gotten, and this was totally guided, but think, how many out of 7 would we have gotten on this if this were an AP portion of the test? Use that to think about, and then use these skills and notes to answer the question that you guys will be working on with your groups next. I'll see you guys back in the whole group.